Alright guys, let's go ahead and do number 100 as well. So we already figured out that x minus 5 is going to be a root because it has a remainder of 0. And we figured out that x minus 2 is not a root and should have a remainder of 15. 100 says, now divide that same problem that gave you a 99 by the factor you chose in the previous problem. If it is a factor, use it and the resulting factor to determine all the roots of the polynomial. If it's not a factor, reconsider your answer to the previous problem and try a different solution. So we know that x minus 5 is going to be a root. So let's go ahead and do that division. I'm going to do it two ways. I'm going to do it using the long division algorithm, and I'm going to use it doing the area model. And which way you use is up to you. Ideally, you would know both. But ultimately, I'm not going to force you into one or the other. So let's do this long division algorithm. This is going to work just like long division that you learned in elementary school. The way this is going to work is I'm going to ask myself, what do I need to put here that I can multiply by x to get x cubed? And the answer should be x squared. So x squared times x gives us x cubed. X squared times negative 5 gives us negative 5x squared. I'm now going to subtract this whole thing. When I subtract, I need to change the sign of everything. That makes that 0. Negative 9 plus 5 adds up to negative 4x squared. And then I'm going to bring down 19x. Now I repeat the process. So now I need to get to negative 4x squared. So I'm going to multiply by minus 4x. Negative 4x times x gives us negative 4x squared. Negative 4x times negative 5 gives me positive 20x. Again, I need to subtract. So change all these signs. That becomes 0, and I get negative x for that. And I bring the 5 down. Things are looking pretty good for us. So in order to get negative x, when I have x, I need to do minus 1 here. So minus 1 times x gives me negative x. Minus 1 times negative 5 gives me plus 5. I need to subtract those. So change all these signs. And I get 0 and 0, and I have a remainder of 0. So what this tells us is that x minus 5 times x squared minus 4x minus 1 equals our original third degree polynomial. This last one, I know that because I have a third degree, I have 3 factors. So I can break down this second degree into 2 more factors. They could be real, they could be imaginary, they could be repeated roots, but there's 2 more. Let's see if I can do it with the area model and diamond problem. So if I do a diamond problem, that's negative x squared. So I would need 2 things that would add to negative 4 and multiply to negative 1, which isn't going to happen, so we're not going to be able to use the diamond problem on that, which is fine. We can go ahead and use quadratic equation. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So 4 plus or minus square root 12 over 2. Square root 12 I can break down into square root of 4 times square root of 3, right? Which will then make this 4. Now, let's do this. That's going to be 2. then I can divide 4 by 2 plus or minus square root 3. So I get some irrational roots, which is fine. So this would be x minus 2 plus root 3 and x plus 2 plus root 3 for my answer. If I distribute that negative, x minus 2 minus root 3, x plus 2 plus root 3 equals 0. And if I multiplied all three of those out, I should get my original third degree polynomial. All right, thanks.